This is the third of 4 presentations on the use of the import add-in option of the gra005 Git Rules add-in project. This option sets up the code architecture so that you can access files that are not in a format that Git can read natively and manipulate them so that they can be imported. And if you have not looked at the first 2 presentations, we're going to be quite lost in this one because we're building on those. And in this presentation, we're looking just at importing Excel data. And this is importing Excel data directly into the target Git database, meaning that we're going to set up the temporary Git CSV file that we're going to create from the Excel data so that its data dictionary, its table and field names match exactly the table and field names on the target database. All right, let's go through the process. So we have a database open. It just has project information, no borehole information. We're going to be importing into the sieve tables and the borehole tables if those boreholes don't exist for those sieve data. And this is the data from gra009, another example add-in on our website. So we're going to be rebuilding that code. And just to show you what we're importing from, we're going to be importing 3 different spreadsheets with sieve analysis information, and the data is scattered through the worksheet, borehole depth, etc. here, and the sieve results here. So the code we're going to write will be grabbing data from the appropriate locations. All right, so let's run the add-in. And here we have the import add-in. Go, procedure name, sieve data import from Excel by me, import sieve data from Excel files. We're going to use the current project as a target structure. Excel files, Excel SX, and XLS. We're going to allow multiple selection, and we're going to be importing from the importing into the point table, the sieve table, and the sieve readings table. In the point table, we want the borehole ID and total depth. We're going to be importing into those 2 if the boreholes don't exist for the data we're importing. In the sieve table, borehole ID, the depth, total weight of specimen, the weighing method, and the sieving tare course. Sieve readings, point ID, depth, sieve size, and the soil plus tare weights. And we're done. Get rules, let's code, add-ins, and paste. So this is what the add-in did for us. It sets up the script. This is exactly the same as the text file import. I'm not going to go over this again. Matter of fact, this first portion here, this first procedure, is pretty much exactly the same as what was generated for the text file import in the previous presentation. And here's where the difference is. This is the procedure where we actually open the files, extract the data, and put them in a temporary Git CSV file for final import. Again, all of this is exactly the same up to this point. Now the cell specification takes over. And the first thing you're going to find, remember, in all of this, in all of these rules for gra005, it will put in comments like this, starting with ... indicating you need to do something here. So we're defining Excel objects. Now natively, our compiler, and actually I don't know of any compiler that natively understands Excel objects, perhaps except the Excel macro programming compiler. So you have to put in a reference to the Excel object. And you do that, as it says, under Edit, References. And this could take a while, the first time you do this in a session. And here are the available references on my system. You're going to find lots and lots of objects that you could tie into to do lots of different things. And we want the Microsoft, oops, too far, Excel object. I have a very old copy here. Here's the Excel 12, which is 2007. Mark that, and then click OK. And now this module understands what Excel objects are. So we can get rid of this comment here. The reason we write it this way, if you skip this step and you tried to compile, the compiler would yell at you, it doesn't understand the statement at all. So get rid of that. And here are two other places. We need to supply a worksheet name. What this does, right here, it opens up the Excel application, turns off display alerts. It's a cosmetic command so that you don't see various things happening when Excel is being run. And then, as with the text files, it splits the source file list into a one-dimensional array, or a vector, to store all the different files that were selected. And then it's going to walk each of the files. And for each file, it's going to open the file using this command, the workbook's open method of the application, and set it to an object. We're calling OBook, which is an Excel workbook. And then we're going to open up a sheet, a worksheet. And you may have more than one. You may have an Excel file that has multiple sheets, and you may reference them by name or by number, and you may need to walk those different sheets. And then, of course, this is where the real work takes place. This we can't do for you. You need to write the code that will grab the appropriate data from the appropriate cells in the worksheet and then store them to the appropriate file. We have a temporary file for each table we're importing into. And you must put the data to these files in the same order as are listed here. You can change this order if you wish, if it makes it easier for you, as long as the two match. And then when it's done doing that magic, it sets the sheet object to nothing, closes the book, the actual file, and then goes to the next file. It continues till it's done. When it's done, it closes the application object, and then from this point down, it's the same as with the import of text files. So I'm not going to actually do this coding. That's quite a bit of work. We're going to bring up gra009, which you can grab from our website and take a look at it in more detail. First of all, there's quite a few constants up front to do a number of things. Locate various rows that are in the spreadsheet where locations of various things are, and various columns, the worksheet name we're working with. And there are three items we're hard coding. for value. The hole depth, if we are defining, if the borehole we're importing, or the civNelse data, if its borehole isn't defined in the current database, we're creating it and the hole depth is required. But we don't know what the hole depth is, so we're going to set it to 0. The sieving method is also necessary to do the calculations in our sieve analysis, and we're hard coding it to a C cumulative because that's what all of these sheets were. If you had a spot in the sheet where you could tell whether it's incremental or cumulative, you could then read that from the sheet. But we're hard coding it here, and the weight of the sieving tare we're hard coding as 0 because that's what was used in all the worksheets. Again, if that field was there, we could just read it from the spreadsheet. Okay, so what is it doing? Up to here, the gra005 did for us. We just put in the sheet name, and we used a constant instead of a hard coding it. We could have put this instead. Prefer not to use literal values within the code. We'd rather use a constant, especially if it's used more than once. And then we start reading it. This is the way you access a specific cell in Excel using the Excel objects. It's osheet.range, and you give the column letter and the row, and it's .text, and that's your point ID, specific row and column, and those three pieces of information give us what we need for the sieve analysis, the sieve parent. And again, we have to put this in the same order as is up here. And we're writing it to a temporary GINT CSV format, so we have to make it comma separated. You could have, and this function here makes that easier. This was discussed in more detail in the previous presentation. And then we have to extract the sieve readings data. And it walks through using the same method. Now, keep in mind, instead of going from using specific cells identified by a specific column and row, you can name ranges in your worksheet, and there are ways of accessing data in a range. It's a much better, much more maintainable way of doing it than specific cells, because if you decide to change the structure of your Excel spreadsheet, have the same data, but in different positions on the worksheet, you would have to change your code. Whereas if you're referencing by a range name, the code would not change. And I'm going to have to refer to you to Excel programming to see how to do that. Okay, and then if we check at the end of each worksheet if the borehole exists, and if it doesn't, we're adding it to our borehole list that we're going to later add to the borehole file. If it does, it doesn't go in that list. So at the end, we've finished going through all the files. We have this point ID list made, and then we write to the point file just the borehole name and the hole depth, which is hard coded to 0. And this function comes along with the auxiliary files we described in the first presentation. We close it up, and all the rest is the same as with the text file. Now, one other thing you have to do, once you've finished writing all that code, remember this, the last step is to go into Get Rules, Add-ins Manager, and add, and we add a, you need to add a record to reference your add-in. And again, this was covered in more detail in the previous presentation. Okay, so let's run this. Add-ins, import sieve, and I'm going to go to source files, pick these three, open them up. Pick the override option, no data here, so it doesn't matter what override option, there's nothing to overwrite. And there we have it. Everything was imported properly. Let's go to lab testing and sieve analysis, and there we have it. We did not import the percent finer. That was calculated. We have all the information we need. So if you wanted to double check, you could add another column to your sieve readings table that has the original percent finer, and program can calculate the new one, and then you could actually write a post-processing get rule, an after save rule. That it's actually not after save, it is the get rule. It's the get rule procedure on save. That would execute after our native save procedure. And you could check and see if there are any differences. So if you want to go that far.